I want to use a real-life example to convince you guys that static friction is actually stronger than kinetic friction. And that even though things aren't sliding, even though there's not physical motion between two objects, there can still be friction between them, and that's static friction. The friction we think of, probably, when we think of friction, is when two objects are moving and sliding across each other, and that is kinetic friction. So here's a real-life scenario. You want to sweep behind the oven. This is an oven. So you start to try to nudge the oven out of the way. And you give it a little nudge. Don't make fun of my drawing. So you apply some amount of force, and the oven doesn't accelerate. It doesn't go anywhere. So we know that if it's not accelerating, the net force must be zero, so there must be an equal magnitude and opposite force vector coming from somewhere that's pushing back on this oven, and that's the force of static friction. Another thing I want to point out is that another important point is that the force of static friction can be higher than kinetic friction, but it doesn't have to be. It can change. Its maximum value, it can be higher than that of kinetic friction. But right here in this situation, when you're only pushing gently on the oven, static friction only has to push back very gently. In fact, if it pushed back as much as it could, which is to say, if you use this equation for friction and you put in the normal force of the oven, that normal force from the ground on the oven, which is equal to the weight of the oven on the ground, and you multiplied it by the coefficient of static friction between the oven and the ground, you would get a really high number. Maybe the vector would, be this long comparative to the small force vector we're applying. And it would be ridiculous to say that, as long as there's a static friction acting, it is of this full magnitude, because what would the net force be if we push gently on the oven and a big static friction force pushed back? The oven would accelerate us backwards, and the oven would push us across the room. So that's just ridiculous. Doesn't make any sense. So the force of static friction is variable. It can change. And it does change as we push harder on the oven. So here's maybe we use both arms, and we apply more force on the oven, it still doesn't go anywhere. So that's because the static friction pushing back becomes more to equal the magnitude of the force we're applying. And now you really put your back into it, and you apply a whole lot of force, and the friction increases to match that force, and then you apply just a tiny bit more force, and you reach that point where the force you're applying is equal to this maximum possible value of static friction between the oven and the floor. And there's a point where the force that you apply is just barely greater than that maximum possible force of static friction. And that's when you have a net force, a very small net force acting to the right. And that net force means that the oven accelerates to the right. And if the force of friction stayed the same right after that oven got nudged free and started sliding, then it would just slide really slowly across the floor. But we know that's not the case. We know that as soon as that oven starts sliding, it kind of just goes really fast across the floor and maybe even slams into the wall. I mean, once it gets loose, it just goes. And if you want to slide it all the way across the room, if you're moving furniture or something, you know that you want to keep it moving, because it's harder to get moving again once it stops. And that's because the force of static friction is higher than the force of kinetic friction. You don't have to push as hard to overcome the force of kinetic friction when it's moving as you do to get it started moving to overcome the force of static friction. So let's go back to that really interesting instant in time when you budge, when that oven gets budged free. What is the word? But anyway, that instant in time when the oven starts moving. Here's what happens to the force of friction. It suddenly stops being an instance of static friction, because static friction is only applies when the two objects are motionless that are rubbing against each other. But as soon as there's motion between the oven and the floor, then it's no longer a case of static friction, it's a case of kinetic friction. And we would use exactly this equation. The force of friction is the normal force between the oven and the floor times the coefficient of kinetic friction. And that coefficient of kinetic friction is going to be lower. So the instant that oven gets nudged free, the force of friction opposing your motion gets drastically decreased. But you don't let up any. You're still putting your back into it and applying all this force. And what does that do to the net force? The net force is now greatly toward the right. So suddenly, you're accelerating that oven at a very brisk rate to the right. So that's the story. If while you're sliding furniture, you always want to keep it moving. But don't slide it, you're going to mess up your wood floors.